Welcome to another installment of Calculus for Beginners and Math with Mac. Today we are going to be looking at tangent lines. So before we really get started, let's talk about what is a line. So you guys may be able to recall from like high school or algebra in general that a line is y equals mx plus b in its most basic form. And you may remember that m is your slope. B is like where your line crosses the y-axis, or how we call it the y-intercept, right? And then what might be a little bit different term for you, but that I know you know, is y as a function, right? Y of x. This is the same as saying like f of x equals mx plus b, right? So that might look a little bit more like what calculus has been looking like for you so far. So let's look at something like super simple, right? So let's start with just y equals 2x plus 0. Your line looks a little bit like this, right? But if I were to go from a point right here to a point right here, this should be 2 and 1, right? And that's how we get the slope. But looking at this from a more calculus perspective, we see that there is a rate of change in our line, right? Which is why, if you recall, if I gave you y equals 2x, the derivative of y is 2, right? Because at any given point, we're changing by like 2 units, right? So, but it's not always that simple, right? So, like, let's look at y equals x squared, which looks a little bit like this, right? Well, you may note that, like, as you draw it, you notice that your hand does something different as you go, right? So, like, at this point, you're going down. Right here, you're kind of going flat, right? And here, you're going up. So, your overall, like, derivative of this function is y equals 2x, but you're not necessarily having the same rate of change at each point on the line, right? So, like, our rate of change at the origin is different than at here or here, right? So, when we are trying to find our tangent line, we need to find a couple of things. Because a tangent line is mathematically defined of f of a, or I think f prime of x is f prime of a, f of x minus a plus f of a, right? Let's scoop this over a little bit. I'm just going to do y tan instead of that. Gonna make this a little bit easier to read too. And this might not look like your normal like y line equation, but it is, because look, this is the slope at any given point, that I'm going to call point P. And then these are just adjustments, right? Because this is B and this is the X, right? So let's look at this really quickly with, once again, just our simple. Let's look at y equals x squared, right? So we'll do this graphically in a moment as well. But we know that, actually, let's make it a little bit easier to write this nicely. So at 2, -2, and this up here is going to be 4. So we're going to have an intercept here. My 2 isn't quite right. Let's put it there. So we have a point here, a point here, and a point over here. Then we have our parabola, right? Cool. So now let's start by looking at any given point. Let's look at point. So we have y equals x squared. Let's find the tangent line where x equals 2. So by knowing this graph, we know that y is going to be 4, but we'll get to how to solve it anyways. So the first thing that I always do for this is I go ahead and find my slope. So let's go ahead and write out steps. So 1, slope of y of x. And quick note here, I'm going to be using x and a. This given point is a, but we'll get to that as well. So y of x. Y of x is x squared. So now I take the derivative to find the overall slope, which is 2x, right? So now, let me bring some of this with us. Let's size it down a little bit. So the second thing we want to do is find it at our given point. And I note that what the given point is at given point. And I know what's given because in my initial instructions, I was told x equals 2, right? So I want to find y of 2, which I just plug in. 2 squared is 4, right? And we can also confirm that because remember, that's where the point is at 2, 4. So we're expecting that to be 4. And then we have y prime of 2, which equals 2 times 2, which also equals 4, right? So now when we plug all this back in, let's make it green. Plug in. We get y tan. And first we do our slope, which was 4 times x minus 2, because that's our a, plus 4, because that's our b. B slope a. So now you're probably asking yourself why, right? Like you've seen this before, but maybe it doesn't make sense. So let's look over at Desmos for just a quick moment. So we have our x squared, and here's our point that we were expecting, right? 2, 4. So let's say I just took the derivative of this, 2x. This is right, but it's not quite at that point, right? It's just the overall. As opposed to, let's say I put in 4x minus 2 plus 4. That's really the rate of change at this given point, right? Just look at this. We have a much steeper rate of change here. Here, look at this. A much steeper rate of change here than we do right here, right? Because say at this point, which I don't think it hit, there it goes, 1 and 1. 1 and 1 looks completely different. So let's look at it back on our notes. Sure. There we go. So anyways, so let's say we looked at this at still y equals x squared, but at x equals 1. And we know that the point is 1, 1, but we'll still prove that. So we still have the same derivative as before, right? 2x. But now when I plug in y of a, I get 1 squared, which is 1. And y prime of a, I plug into y prime, the 1, and 2 times 1 is 2, right? So now my y tan is 2x minus 1, because remember that we have this a right here, plus 1 from our b, right? Now let's see what this looks like. Okay, so if we look over here, we now have our tangent line equations, right? At point 1, well, at point x equals 1, sorry, and at point x equals 2 is up here. Let's zoom in a little bit better. There we go. So you'll notice that these are two different slopes, right? Which makes sense because this point is just not nearly as steep as this point. So all the tangent line is really doing is making sure that we find the point, the rate of change at a given point. And this part is just adjusting, right? Because we had, let's go back to our notes to explain the adjustment, actually. So we know how we've done y equals x squared, but we run into an issue, right? Because the derivative of y equals x squared plus 7, or y equals x squared plus 1400, or y equals x squared plus 1, all have the same derivative y prime equals 2x because that y-intercept is dropped because it's constant, right? And there's no rate of change without a variable. So say we have y equals x squared plus 7, and we want to go back to our point at x plus 7. One thing that's very important on tangent lines is making sure that it actually does intercept. So let's go see. Sorry. Sharing my screen to find where it intercepts. Let's scoot it down. Let's do x squared plus 4. Yeah. Just to make it a little bit nicer. So now that gives us 0.828. Yes, it does. So let's stop share and go back to the notes. Let's change this to just for the 4. At x equals 2 again. So our y prime is still 2x because the only thing we've done is add a constant, right? So you might think to yourself that y of a shouldn't, like, you may think that your tangent line should just have that 2x, but it doesn't, right? Because we need to plug in 2 to the original equation, which would be x squared. So 2 squared is 4, plus 4 is 8. And we now need y prime of a, which is still the same before, right? 2 times 2 is 4. So now we have y tan equals 4 x minus 2 plus 8. And here's why. So let's say we just did y equals 2x. Well, this isn't quite right? Because for it to be a tangent line, it needs to intercept with the point that you're looking for. It's like if I asked you to kick a ball into a soccer goal, you have to account for the foot kicking the ball, right? Otherwise, you're not kicking the ball, you're kicking the air next to it. So you have to include your point. So now let's try scooting it over, right? So we scoot over back to the x. Well, this is close-ish, but not really. So now we have to go up 8 to touch it. But we have to fix our slope to actually match what the slope is at this point. And so basically what you're doing for tangent line is you're finding the slope at a given point, or the rate of change at a given point, by taking the derivative and then plugging it back in. And then you're using your algebra topics, such as like x shifting and up and down and side to side, to actually get that point. Because say if we didn't shift it, well, now it's all the way out there. It doesn't help us, right? Or if we add the 8 but take out the 2, well, now it's in the middle and that doesn't help us either. We have to include the point. So hopefully this quick lecture will help with tangent lines and you will be more equipped to be able to take on any that you want. Feel free to try these on, you can create your own tangent line problems. Just make sure that when you're looking for a point, it must exist on the graph. For instance, if we were doing equals x squared plus 4, and we were looking for the point 1, 7, that wouldn't be possible because 1, 7 doesn't exist on the graph. So, hope this helps. Have a good evening or morning wherever you are.